Okay, so today we're going to talk about compound events, and the idea is that it's multiple events, and so successive events, and the idea is it's going to be in the form of you're going to see something like flip a coin, flip three coins, or pick two marbles, or yeah, and so. The idea is in any problem when they say like do like or spin us. The idea is you're not going to flip three coins at the same time. You're going to read this as flip the first coin, then you're going to flip the second coin, then you're going to flip the third coin. Same idea with picking two marbles. That's going to be the thrust of this exercise to help you understand it. You're not going to pick two marbles. First, you're going to pick the first marble. Then you're going to pick the second marble. Same thing with like students. Pick two kids. You're going to pick the first kid. Then you're going to pick the second kid. Okay. So the notation is the notation for the two events. Let's talk about two events, A and B. And so you're going to see the probability of A and B. In general, this is going to mean the probability of A, then B. Okay? And here's the great part. So it actually is equal to the probability of A times the probability of B, okay? And so I might say, what is the probability, given, so you flip two coins, and what is the probability that they're both heads? Okay, so you're not gonna flip two coins. You're not doing that. You're gonna flip the first coin, and then you're going to flip the second coin. Right? Well, we know this is 1/2 times 1/2 is 1/4. Now, you could have made a table. You could have said, okay, here's the outcomes. Here's, the first coin. The first coin is tails or head. Here's the second coin, tails or head. Tails, 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 head, heads, tails, heads, head. They have all equal chance, so it's 1/4, and so we have this is 1/4, 1/4, 1/4, 1/4. The probability is 1/4, but we don't want to make a table because in the last example I asked you to do like roll two die, and I don't want to make a table for 36, so we need a faster way. So the probability of a compound event, which is one event, then another event, is the product of the individual events. So it seems very basic, right? But the problem is, the thing we need to think about in probability is, does the first event affect the probability of the second event? So we need to think about this. Does the first event affect the probability of the second event? If no, then the events, we say they're independent. Independent. If yes, then B depends on A. So that's what we need to think about. Does the first event affect the second event? Well, let's see. So, yeah. A couple of words. So in the next couple of exercises, so okay, let's move on. So let's see. Okay, some independent events. Flipping a coin. If I flip a heads, it doesn't matter. It's not going to affect the next roll, the next flip. Same thing with like rolling a die. So let's say I roll a die and I get a 1. Now, does that mean I can't get a 1 on the next roll? No, the probabilities don't change. Probabilities don't change. Same thing with the Punnett square you learn in biology class. If you have a sister and your parents have another baby, it doesn't guarantee that your next brother or sister is going to be a boy or a girl. It does. They're independent of each other. What's dependent of each other? Well, we're going to look at an example. Dependence. An example of dependent is something called without replacement. Without replacement. So what does that mean without replacement? Well, here's the example. Oh, sorry. Here's the example. So let's imagine that you have. Let's imagine that you have a bag of marbles. A bag of marbles. Okay, and in this bag of marbles, you have 5 red, you have 3 blue, and you have 2 yellow. Okay, we could do some basic probabilities. Let's go through some probabilities. What is the probability of red? Yeah, 5 over 10. Because there's 10 marbles in the bag, 5 of them are red. The probability that you're going to get a red is 5 over 10. What's the probability of not yellow? Well, the easiest way is just to change it to 1 minus the probability of yellow. We know the probability of yellow is 2 over 10. Therefore, the probability of not yellow is 8 over 10, or 80%. Or 4/5, or whatever, the 80%. What is the probability of picking black? A black marble? Well, you say, Mr. Adler, there's no black marbles in there. Remember, this was blue. There's no black marble, so that's never going to happen. Okay, cool. Now let's get into it. So I'm going to ask you, what is the probability, right? The next thing I'm going to ask you, what is the probability of picking a red than a blue? But I'm going to tell you about 2 scenarios. 2 scenarios. Now you say, okay, fine. It's the probability of red times the probability of blue. And you say, fine. We know that red is 5 over 10, and the probability of blue is 3 over 10. Well, that's not going to be the case, because in the first case, it's with replacements, which means you're going to pick the first marble, probability of red, and then you're going to, the first case is with replacement, which means you're going to pick the red marble and then put it back in the bag. So the probability of red is 5 over 10, and the probability of blue is, first of all, I put the marble back in the bag, which means I have my 10 marbles, there's 3 blue, we have 15 over 100. There's a 15% chance of picking a red than a blue with replacement. The second case is without replacement. Without replacement, I'm not putting that marble back in the bag. Let's see what's going on. Same scenario. I pick a red, then I pick a blue. The first marble, I have 10 marbles in the back. There's 5 of them are red. But after the second action, there's only 9 marbles left. 3 of them are blue. Final answer, 15 over 90, which is, let's divide it by 3. 5 over 30, 1/6. Final answer, 16%. So we see without replacement, it changes it affects the second probability. In this case, B is dependent on A. Let's try another example with or without replacement. Blue, then yellow. Let's say the probability of blue, then yellow. So 2 cases, with replacement, without replacement. Okay, let's see. Well, it's both cases, it's the probability of blue times the probability of yellow, but we've created different situations. With replacement, the probability of blue is 3 over 10 times 2 over 10, which is 6 over 100, or 6%. What's going on over there? Well, blue is the first event, so, and we're starting over again. We're back with our 10 marbles. We still have 3 over 10, but 2 over 9. 6 over 90 divided by 3. 6. 1 over 15. This is 6%. So we see it. Does it change that much? Actually, it does, because this is 6.6. Sorry. This is 6. So the probabilities do change based on the scenario. Let's try another problem. How about the probability of 2 yellows? Same idea. With replacement, without replacement. With replacement, the probability of yellow times the probability of yellow. So it's 2 over 10 times 2 over 10, which is 4 over 100, or 4%. Let's try without replacement. The probability of yellow times the probability of yellow, but the probabilities are changing now. The first is 2 over 10 times 1 over 9. 2 over 90, 1 over 45. What is 1 over 45? Hey Siri, 1 divided by 45.
1 divided by 45 is about 0.02222.
2.2%. Should we try another one? What is the probability that both marbles are the same color? Let's see. What is the probability? The probability both marbles are the same color. Okay, so how are we going to deal with this? Well, first of all, let's look at the situations. We have the probability of red, then red, or the probability of blue, then blue, or the probability of yellow, then yellow. Let's keep it simple this time. How about we do without replacement? Let's do without replacement. So the idea with probability is you have to add up all the different outcomes, the possibilities. Well, let's see. What is the probability of red? Let's see, it was 5 over 10 times 4 over 9. Remember, we're not putting that marble back in the bag. Or we have, what was blue? Let's see, 3 over 10 times 2 over 9. Or, you notice I put the plus for or, multiplication for and. Can you see all the way up there? There you go. What's the last one? Yellow and yellow. 2 over 10 times 1 over 9. So we have 20 plus 6 plus 2 over 90. 28 over 90 is equal to 31%. There's a 31% chance that if you pick 2 marbles out of the bag, both of them are going to be the same color. Now, in all these exercises, I've told you the specific order, but sometimes you don't know the order. So that's one thing you have to pay attention to. Are they giving you a specific order? If not, you have to, like this, you have to go through all the possible outcomes. So if you pick 2 marbles out, we know it's individual. But let's say the idea is you grab 2 marbles. What is the probability you're going to see? And what was the example I wrote on my notebook? One yellow, a yellow, and a red, in no order. So what is the probability of picking a yellow and a red? So you said, well, I don't know the order. So it could be, and let's do it without replacements. Actually, it doesn't matter. You have to cover both situations. But let's do it without replacement to make it clear. So it's either you pick yellow first and red second, or you picked red first and yellow second. If you're replacing it, it doesn't matter. You do have to acknowledge that there's 2 possible outcomes. But if it's without replacement, it affects the probability, and you need to pay attention to that. So once again, we have 2 over 10 times 5 over 9 plus 5 over 10 times 2 over 9, which is, 20 over 90, which is 2/9, which is 22%. Please pay attention if what did I write? Pay attention. Does the first action or event affect the second probability? Does the first event affect the probability of the second event? That's the most important thing here. Are the probabilities changed? Good.